Hello, everyone. Welcome to today's webinar. Thanks for joining the Novedge team and in presenting VisualARQ 2 Flexible BIM for Rhino and Grasshopper. The webinar will show an overview of the flexible BIM features VisualARQ 2 adds to Rhino, focusing on the new features specifically. So this webinar is going to be packed with practical and technical information. Don't go anywhere. Today's presenter, Francesc Salla, is an architect graduated at the ETSAV in 2008 and joined Asuni in 2010. Francesc is the product manager of VisualARQ and Lens Design, the two main products of Asuni. Novedge is one of the largest online stores for design software, and we offer a huge assortment of software solutions just like VisualARQ and Rhino. So if you want to check out both products, visit us at novedge.com. And for more daily software news and limited time promotions, pay a visit to the Novedge blog, and we're also on Facebook, Google+, and Twitter. Coming up next week, what's new? Rendering with KeyShot 7. And last but not least, today's webinar is free and is being recorded. So if you want to rewatch it, just head on over to Novedge's YouTube or Vimeo channels. And now I will share Francesc's screen and get this show on the road. Okay, we see.
Okay. Thank you very much, Barbara, and welcome everybody from any part of the world. It's good to see that, many people are attending the webinar from worldwide. So today we'll show the main features of VisualARQ 2. So for those that maybe don't know VisualARQ at all, we can say that VisualARQ adds flexible BIM features to Rhino to make the process of modeling and building architectural projects inside Rhino faster and easier. So when we say that adds BIM features, is basically that all the information is stored in the 3D model, and all the documentation is generated out of it. Okay, so everything is managed from the 3D model. So also because VisualARQ provides this set of architectural objects, they are smart objects, and they can be changed parametrically. Also because VisualARQ adds the option to change models using IFC file format. But you know that all these smart objects, when they are exported to IFC, they are recognized as smart objects also in the program where they are opened from. In case of Revit, some VisualARQ objects are recognized as native Revit objects, okay? Such as the case of this model you can see in the screenshot. And we say that adds flexible BIM features to Rhino because takes advantage of all these features to work with complex geometry, okay? Freeform geometry. That way you can create this complex architecture. Also because any geometry in the model can get information that will be stored in IFC models. So for example, in the case of this polysurface, we can tag it as a slab, as an IFC slab. So when this object is exported to IFC, it will be recognized in this case by Revit as a Revit floor. Okay, so no matter how many objects or different or complex they are in Rhino, that you can assign information to them and export them to IFC. And flexible, especially because it's completely integrated into Grasshopper. So in addition to the VisualARQ Grasshopper components that were already in VisualARQ 1, we have added a new option to integrate it with Grasshopper that I will show later on. Okay, so basically the existing integration with Grasshopper consisted in the option to create all the VisualARQ objects directly from Grasshopper using these Grasshopper components. So now let's take a look, an overview of the new features of VisualARQ 2, and later on we'll show them in a live demo. Okay. So the first one we could say is the option to print the model in hidden line vector output. That means that you can directly have the 3D model, show it in plan views, in section view, in perspective view, and print that in vector output. Okay, so no need to generate a make 2D out of it or a VisualARQ former plan view, section view to add additional 2D lines in the model, because you can just show the model in section, show the model in 3D or in plan, and print that directly to PDF output. Okay. Then we have this new feature of integrating VisualARQ with Grasshopper, consisting in creating any VisualARQ object from a Grasshopper definition. And this allows hundreds of different possibilities, since all the objects are created from Grasshopper. So we'll see a few examples of this integration. Also, we have improved the level manager, okay? And we have added a new section manager that lets you manage the sections of your model, as well as showing the model in section from one section line or another, okay? We have added 3 more smart objects, which are the furniture, the element, and the annotation objects. So the first one is aimed at furnishing elements. Second one is aimed at any other object doesn't fit in the object type of the other VisualARQ objects. And finally, we have a documentation object aimed at 2D symbols. Okay, but all of them can be created from Grasshopper, allowing also having smart options and parametric options for creating these objects. And in case of the furniture and the element objects, they can have a different representation in model view than in plan view. So for objects that are very detailed in 3D, but you just want to have a simple 2D representation, you have the option to change the 2D representation than the 3D. Also, we have added the option to add multiple parameters, custom parameters that can be created from document or for any particular style or object. And this information is also stored in IFC files, okay? And they are typed. So we will see some example of this option to add custom parameters. Also, there are more options to do Boolean operations between VisualARQ objects and Rhino solids, because in VisualARQ 1, you could only subtract solids and add solids to walls, but right now it's possible with any other VisualARQ object, and keeping the parametric functionality on these objects after these Boolean operations. We have added more intersections for roofs, so they intersect each other, allowing more options for roof design. Also, we have added joints for beams and different options at cap ends. Okay, you can define the ending of a beam vertical, horizontal, or perpendicular. All right. We have improved the way VisualARQ imports and exports IFC files from Rhino to other programs, and also added support for external references, okay, which is important if you want to work in the same model with different users. And after every user finishes their part of the model, you can just go to Block Manager, update the part that is inserted in the, let's say, master model, and update with all the changes. And VisualARQ objects are shown correctly and are displayed correctly. So VisualARQ 2 is free to upgrade from VisualARQ 1 users. So if any of you has a VisualARQ 1 licenses, you can go to the VisualARQ website, go to the download update, and you will receive a free license key for VisualARQ 2. Okay, and also the licenses are like Rhinos. I mean, there are educational licenses available that can be used for professional purposes. Licenses are permanent, and there are no maintenance costs. And at the website, you will find a 30-day trial version available. But if you need more time to to keep on testing VisualARQ, just send me an email to any of these addresses, and I will send you a license key to extend this trial period. Okay. Now let's see the new features live in this model. So first of all, here you have the main VisualARQ toolbar. As you can see, we have added these two new objects, the furniture and element. Here in the documentation toolbar, we can see the new annotation object, okay, and also the option to open the section manager, okay, that we'll see right now. Finally, we have added more commands, as I was mentioning before, for adding solids to any VisualARQ object or subtracting solids from any object, extracting solids that have been added or subtracted as well, or these commands to quickly select the VisualARQ object. So if you want to quickly select all walls, you can just do it from here, or you want to select all the doors. So same thing. Okay, they are shortcuts to select objects from the same type, or just select all the VisualARQ objects. Okay, as you can see, there are objects that are not VisualARQ, so this really doesn't matter. In one model, any kind of geometry can be created, okay, and can live together. And after, in terms of generating documentation, it really doesn't matter if they are VisualARQ objects or Rhino geometry. So great. So let's see the improvements on the new level manager and section manager. When we open the level manager, we can see this. There are some existing levels here. This hasn't changed so much, so you can show and hide levels from these lights in here. But we have added these two buttons that basically let you, for example, if we are in top viewport and we just rotate this, in the first case, this button aligns view to one specific level and also activates the cut plane on that level. As you may know, when the cut plane is on, all the VisualARQ objects show the 2D representation. Okay, while if we rotate it, they show the 3D view according to that cut plane. So this is basically a shortcut to put the model in plan view and also activate that level. But if we want to make something similar but making a zoom extents, we can click on this button instead. And also this button changes the display mode into hidden, which is the one that we will need to use to print that in vector output. Okay, so if we had this, for example, in perspective view and realistic view mode, and we want to quickly put this viewport into a plan view, so it not only activates the cut plane and makes a zoom extent, but also shows the viewport in this hidden display mode. Okay, so in a similar way, there is the section manager. Okay, that again you can open it from here. Actually, you can open it from the panels list here in Rhino, doing that right click and selecting it from here. Okay, and let's do something. Let's put this level manager, section manager down there so we can see level and section manager at the same time. Now, in this model, we already have some sections. I mean, if we want to click and see where these sections are, so we can see them just selecting them, right? So A, B, and C. Now, if we want to see the models sectioned by the section C, we just need to select this section and just click on this toggle section button. And this shows the model in according to the position of this section line. Okay, we can double click on any other to switch from one section to another. Okay, but as long as this button is on, it will show the model in section according to the selected section line. Okay, of course, we'll update when moving the section line. Just notice that VisualARQ objects show hatch pattern, okay, according to the styles properties. And just a reminder, you can also assign these section attributes to also Rhino geometry. So in this case, this is a closed polysurface, and remember that we can assign any section attribute from this button here. So we can assign, for example, a single hatch pattern in that scale and rotate it 45 degrees. Okay, maybe a more dense scale for this in this case. And also you can assign lightweight, so forth. Okay, now let's act in and check the section view. And when we are in another viewport, again, we can say that in this view, we want to see the section C. So again, this button just aligns the view to the selected section, but doesn't change the zoom or the display mode. While this other option makes the zoom extends to align that view to the position of the section, and also changes the view mode, display mode to hidden. So this is important again, because when we are ready to prepare the page layout, imagine that we have here, this is the page layout with a couple of detail views. We can click inside one detail and, for example, set in this level, the level 0. Okay. So, and while in this level, we want to see level floor 1. So again, we need to click the cut plane now. And this is just ready for printing purposes. Okay, so we can print that in vector output, and we can do the same in this page layout for sections. So we can say that in this view we want to see the section C. Okay, so which aligns it with the section C, and also changes the display mode into hidden, which was basically it was in hidden already. Okay, but you can just select this, click here to orient it to the section B, which was already. But there is a quick way to prepare the detailed viewports with one section or one plan view, and you can actually do the same with the model view. Okay, so we have here a section view. Actually, we can create. Let's go back, because I want to create a section from more than one point. So this is also possible. I mean, we can just, let me uncheck disable the snap points. We can create just a section line that it's a jogged section. Okay, this is important that the depth to define the depth of this section view, because only objects included in the area defined by this depth will show up in section views, okay, or when we activate the section line. So, okay, so I click here, finally give a name to that section line called D, and we can see the model section also from section D, from a jogged section line, as you can see here. Okay, and the same we can do for the 3D view. We can come here and say, okay, I want to section the model from section D. And this is also ready for printing in PDF. So let's take a look at how it looks like. So we run the print command. We made sure that view is in hidden display mode. Okay, so we define the printer settings, make sure this is vector output. All right, so we print that. And let's call this 3D view, for example. Save that, and let's take a look. How is the result like? Okay, so we take a closer look. We can see this is already vector lines. Okay, so it's a straightforward way to have the models directly ready for printing purposes. Now let's back to the model, and let's see this feature to create visual objects from Grasshopper, which is basically one of the most attractive new features of this version. So as you may know, up to the 1.9 version, visual objects, for example, this window, had already some properties to well, to have different designs. For example, you could design. Let's take a look at the window style properties. For example, for this case, you could decide where it has a frame, which are the dimensions of this frame, or how many leaves it has, or the aperture type, and so forth. But you can't have, let's say, you can't create a garage door, for example. Okay. In order to cope with this limitation, there was the option to, which it still is, to assign a 3D block for the representation of this window. And also you could use a 2D block for the plan view representation. Okay. Now, what if we could create this object from a grasshopper definition? So this is basically what we have done in this new version. Let's go back. I will show you a grasshopper definition. We'll open grasshopper, and we'll open a definition that generates a garage door. So this is the grasshopper file, and we take a look at the result of this definition. So this definition has some inputs, okay, that define the shape of this garage door, such as the opening and the width and the height, some aperture as well, and some other options like the leaf thicknesses or the frame dimensions. Okay, basically parameters that define the shape of this object. So inputs on one hand and outputs on the other hand. So these outputs are basically geometry params. Okay, so are basically these kind of components that when they are in at the end, so I mean there are no other, they are not connected to any other component. Later on, VisualARQ will recognize them as output components, and just by giving a name to it, I mean this is called leaves and this is called frame. Okay, VisualARQ will be able to identify each one as a new part of the new style. So let me just delete this. Okay, and also there are some geometry components that they have assigned for the 2D representation, since these objects can have also a different plan view representation than a 3D view. Okay, another important thing to take into account when creating an opening, in this case a door from Grasshopper, is that the middle bottom point of this door must be on the 0 coordinates. Okay, this is very important in order that the opening of this door matches with the shape of that geometry. All right. So when you create more examples, just take that into account. Now we save this file. We close Grasshopper now, and we'll go back to in this case, the door styles to create a new style from that Grasshopper definition. So when you go here to click the new button, you can see that there is an option for Grasshopper style. So let's click this. We'll browse for our file. Here it is, garage door. Click next. You can see here that VisualARQ reads the geometry generated by Grasshopper. So we define a style's name, a definition units, because the units in the definition might be different than the documents of this file. And also here you have the option to select one profile in the definition to perform as the cutting profile of that door on a wall. When the option is set to auto, that means that this profile will be automatically calculated according to the bounding box of the geometry. But in other situations, it's maybe useful to have one geometry param in the definition that performs as the opening. I mean, it must match with the shape that you want to cut through the wall, and then assign it here. Okay. All right. We click next, and here we can see the 4 components we had in the definition with no other connection at their outputs. Okay, and we can assign each them to the plan, to the model representation, or to the plan representation. So the leaves 2D and frame 2D will be assigned to the plan representation, or you can decide whether import one piece of geometry or not. Okay, having all these objects in different components is very useful in terms of assigning materials or 2D attributes later on differently for each one of them. Now, in this step, we can see the list of all the inputs that were in the Grasshopper definition. And each parameter can be editable by style, by object, or by definition. By style means that it will affect to all the objects that have the same style, okay? By definition means that this parameter will be hidden from VisualARQ dialogues when we insert this object or when we edit it. I mean, for example, we have here some integers in the Grasshopper definition that we don't really want to see, okay? Because they were used for calculation purposes only. So we just leave them editable by definition. But the aperture is something that we want to change by object individually. And also you can change the type. So in this case, we will assign percentage type. So there are other parameters. We will leave editable by objects, the height and the width. Okay, and the rest will leave them editable by style. We click finish, and now we have the garage door as a new door in our list of the door styles. Again, remember that here we can select each one of the components, okay, and we can assign like different attributes here. We can assign different layer, different kind of visibility and materials, and also projection and section attributes. Okay. Okay, we close the dialog, and we are ready to insert that garage door and see how it looks like. So we select here the garage door. We click here to insert it. And now if we select it and we take a look at its parameters, let's move this down, we can see the parameters that we left editable by object. So we can change the aperture to 75, for example, okay? Or we can change the opening height and width. Just notice that these parameters went to the geometry category. And this happens because in the Grasshopper definition, if we take a look back, I group these parameters with that geometry name, okay? And then VisualARQ automatically recognized these objects belonging to that category, and they were placed in the corresponding group. And the same for the aperture. This goes to opening, and for that reason, when we select this door, we see that the opening height and width are placed in that geometry category. I mean, we can change that to see how it changes. Okay, and that's why this aperture goes to the opening category. All right. So the advantage of this integration of VisualARQ with Grasshopper is that there are no limits now to create parametric objects. Okay, and that someone who doesn't know Grasshopper at all can use objects run by Grasshopper, because actually this object is driven by Grasshopper, which is running in the background, even though you don't notice it. Okay. And also, of course, we can take any other door, for example, this one, and we can change the style for that new one that we have just created, the garage door. Okay, wow, this is too big, so let's change the height. Okay. All right, so let's move on. All these objects, this option to create objects from Grasshopper definition is currently available for any kind of object except walls and curtain walls, which is something that is in development, and hopefully in a few versions it will be available. But it's especially interesting to see how they apply on these two new objects. Okay, if we take a look at for example, the element object. Again, this is an object aimed at any kind of object that doesn't fit in any of these types. So it could be, for example, a sink or stove burner or a tree in this case. We have actually here a tree placed in the model. And in this case, this object is created from a 3D block for the model view and 2 block in plan view. I mean, we put this in plan view, we see the 2D representation. If we uncheck this and only have assign a 3D model, the plan view representation of this object will be the real cut of this 3D block. Okay, but as long as we assign a 2D block, this one will replace the 2D representation of this tree. So let's take a quick look at this tree in plan view. and we see that this is actually the tree shown in plan view. Okay, great. But again, these objects can be created in from Grasshopper definitions as well, and same for the furniture elements. Let's take a look at a Grasshopper definition that generates a wardrobe. Okay, because we will create a parametric wardrobe. So I will open a Grasshopper definition for this wardrobe. Actually, this is a definition that already comes with the VisualARQ templates. So if you open a new file from a VisualARQ template, you will be able to use this object, okay? And also all these different other objects. So again, we have here one object that has some inputs. So we have the width, the depth, height, okay, a number of doors, etc. Okay. Also, we have different here a list that we can switch the 2D representation of this object from 3 different options. Okay, and at the end, the important thing is that we have one geometry for the body, another for the doors, another for the handles, and also a 2D parameter for the 2D geometry. Remember that all these components are geometry params. Okay, and since they have no ends, VisualARQ will recognize them as ending parameters to use as different components. Okay, we save this, and now we open the furniture styles. We'll create a new style and select Grasshopper style. The other one is just an object that uses a block for the 3D representation and block for the 2D, same as the tree. But we'll select the Grasshopper option. We browse. Let's look for that definition. Here it is. Click next. And also you can define one reference point in the definition as a point that can change the geometry of this object, which is not the case now. But later on we'll see an example which it is. So click next. Here we can see the different components. Okay. So in this case, the 2D representation component goes to the plan view. Click next. Here we see the list of all the parameters. So let's say that alignment is something that goes by style, same as the number of doors, and well, the general sizes like depth, height, and width. Okay, and the plan display type is something that we want to also change by object to see how it goes. Click finish. Click OK. And now we can go to for example, the terrace floor, and we will insert this wardrobe in this room. So again, we have here the 2D representation, 3D, all the insert parameters that were editable by object. So we can insert here, okay, and align it accordingly. And just notice that the object show the 2D representation, even though if we rotate it, oops, I think I placed it in the wrong position. Excuse me for that. Let's insert it again. Make sure the project OSNAP is on, so it goes in that floor and not another one. So again, now if we rotate this object, oops, now it is. We see that yeah, the 3D representation, the 2D representation switches to 3D as long as we show that in 3D. Okay, and we can come here and change the width or the height or whatever of these parameters that were editable by object. And finally, I will show you another example of this integration using the annotation object. So we'll see another example. So we'll open Grasshopper again of a definition for generating an elevation mark. Okay, so we open this file, elevation mark. Here we go. And if we take a look at it, we can see that the inputs are one reference point, okay, that well, picks one point in the model. And as you can see, the definition shows the elevation of this point according to the z value of this point, z coordinate. And there are some inputs for the, well, for the shape of this symbol, the offset position of this text, or the number of decimals, okay. And at the end, we have one parameter for collecting the 2D geometry of this symbol, another parameter, which in this case is a hatch pattern param, that collects hatch patterns. It is important to use this hatch creator, which is basically a component that can be found in here, okay, create hatch, in order to, when we create a style from these parameters, this is recognized as a hatch pattern, okay. And the same for the text. So we need this special parameter, text parameter, that can be found here next to the other ones. Okay, these are parameters provided by VisualARQ, same as the hatch one. Okay, and if you want to create it, I mean, to specify the location or the text or all the options, such as the bold, the font, head, etc. You need this text creator that can be found also here next to the generics. Okay, create hatch and create text. So now all these three components will be recognized by VisualARQ as three different components for the definition, for the new style. We save this, we close Grasshopper, and now we open the styles dialog for the annotation object, create new style, select Grasshopper style. So here we will just select this definition, elevation mark. And after defining the name and the units, now it is important that in this case, we select that point that was referenced in the definition in order that it computes the the elevation data. Okay, otherwise we'll replace it always in that elevation that it was before, the 1.19. Okay, we click next. We specify which components we want to import and which don't. Next, and here we get the list of all the parameters in that definition, and finally click finish to have the object ready to insert. So we can now place one elevation mark on that terrace. So we just select that elevation mark. Okay, and now we can place another elevation mark on that terrace floor. Okay, and we can see the different elevations of each one. And again, if we move it this in vertical, we can see how the value updates according to the position. So basically, as you can see with different examples, this integration of VisualARQ and Grasshopper lets you create hundreds, unlimited options for parametric objects that can apply to all these objects, but also to annotation objects. Okay, so let's move on. At the beginning of the presentation, I was mentioning that you can create also custom parameters for VisualARQ objects, but also for Rhino objects. Okay, and these parameters can be created by object individually, by style, and by document. So let's take a look at how to create them by document. So if you go to the VisualARQ tools, under this icon here, you can open the Rhino options from document properties at this parameter section. And here you can add new parameters to the document. For example, we can create one called material. Okay, we select a category. For example, this goes to general. And finally, a data type. In this case will be text. Okay, or we can add a new one called, for example, manufacturer. Okay. And again, this also goes to one category. Can be actually a custom one, not necessarily one of the existing. And again, a data type. So click OK. and we can add as many parameters as we want. And now when we select any object, could be, for example, this tree over here, or I don't know, this column. If we take a look at these icon parameters, we can see, oops, sorry for that. Okay, let me open the model again. We will review this bug later on, hopefully fix it in the next version. So very quickly, we'll create the new parameters again. Okay. So it was one called material, right? That went to general, and another one for was manufacturer. Okay, we need to specify a category. Let's call custom. Great. We click OK, and now when we select any object, for example, this poly surface here, we can see that it already has this field here, the material, and also the manufacturer under this custom category. We can add any information to that field. Okay, so this goes for Rhino geometry, but also for VisualARQ objects. Okay, maybe there was a problem with that column, so I prefer not to select it now, just in case. But yeah, the idea is that you can create as many new parameters as you want and fit the geometry with this information that, by the way, all this information will be stored in VisualARQ objects. Okay, and you can also assign the information by a style. So, for example, in case of this window, if we take a look at it styles, we can go here and see the manufacturer is XXX, whatever. Okay, and now anytime we select windows like that, we can see that the information of the manufacturer is the one assigned by style. But of course, you can overwrite it by any other value. Okay, but in case of VisualARQ objects, all this information can be stored by a style, or they can have a specific parameter that only applies to that style. Okay, so we can create a new style here that will only be assigned to that style and not others. Okay. Also, these parameters, these custom parameters, can be created from Grasshopper. So let's take a look at one definition. Okay, that generates, a structure for holding this ceiling. Okay, so this is basically a reference. This is basically a reference surface that is exploded, and well, just taking two of their edges, I could subdivide each edge in certain number of points. And finally, I've joined the points to create some lines, okay, that you can see here. And just by changing this value, we can see the different subdivisions. Okay, and finally, using these lines, I have created a VisualARQ BIM object. Okay, remember that here you have all the objects available for Grasshopper. So there were standard BIMs. So if I wanted to assign a specific style or specific size, I've used this wall options component that basically lets me the option to assign a specific style. This one just is a component, a param, that lets me reference one style. Okay. And also there are components to deconstruct the information of objects or information of the object styles. So Always, all the components related to BIMs are located under the BIM. So here we could use the construct BIM style to get the list of sizes, okay, that we can see here according to that style, and just picking one of these styles from this list, okay, and assigning to the profile input of these BIM options, we can change the size of those BIMs, okay. So finally, let's set less number of BIMs. Once I have the BIMs, I have used now this component set property to fit these objects with information. So in this case, I have it with a parameter name. Here you have a list of property names param that list all the existing native parameters of visual objects. Okay, let's call it that way. So I could assign like a different name to each one of these BIM, just mixing the text BIM number and some integers that goes from 1 to 5 in this case, okay, according to the number of BIMs. But on the other hand, I could also create a new parameter using this document parameter component, okay. So this lets me create a new parameter that will be called weight. And as an option, I need to assign which category it goes, which is the type. Okay, this is a number. Okay, and also some description, same as the options that are available when you create a new style, a new custom parameter. And finally, the value for this weight will be calculated according to one existing property of these BIMs, which is the volume. So if we know the density of the steel, in this case, and we know the list of the volumes of these BIMs, we can calculate the weight of the BIMs. So this is what I've done here with this component. So I get the list of BIMs on one hand, the property weight on the other, and the value calculated from this component. So finally, when I bake these BIMs, they become well, BIMs in the model with the corresponding name, and also the weight component is also created in the document. Now let's quantify this information. So you know that you can do this with table of styles, but first we need to create a table of style for quantifying BIMs. Okay, right now we have only 2 styles for quantifying opening and spaces. So we'll create a new one. We'll call them that BIMs. And here we need to select the object it refers to. Just notice that you can also quantify not only visual objects, but also extrusions, polysurfaces, meshes, blocks, okay? Any kind of geometry in the model. So in this case, we are only interested in BIMs. So we here specify that the property fields we want to appear in the table, in this case, name and name. We can add a new more. Actually, those parameters created from document are not visible in this wizard. Okay, so we need to assign them afterwards. In this case, we will just set that ready. It was weight. Okay, and click next to assign that property afterwards. So here we have the BIMs with the name and the weight. And now here we can assign from the source tab the corresponding parameter. So we have the type BIM, style could be any, and the parameter now would be the weight that now really appears in this list. We say OK, and now we're ready to insert the table, selecting the BIM styles for BIM. We can select these BIMs and finally insert this list in the model. Okay, so yeah, we can quantify all this information, even if it's for custom parameters, and of course you can export that table to Excel. So just a couple of last things of the new features of VisualARQ. One about the space object that has had some improvements as well, such as the option to set some object for being calculated for the space area. For example, here in this room, We have one dining room with one kitchen integrated. This is a curve. So when we insert a space in here, let's call this dining room. Okay, this space calculates the whole area. But what if we wanted to remove this part of that area? So now, if we run this command element set and select this curve, now this area is removed from the rest of the area. Okay, so whenever we move this curve and we update this space, it will remove the area about this curve. Okay, so let's undo the movement and let's now. Let's move this back here. And now we are ready, for example, to create a new area for that curve. Remember that space object can be created also from curves. Okay, so we'll call this kitchen, and maybe we can select a different style. Okay, remember that with the control points we can move the position of that level. Okay, and just for finishing this presentation, in this model I have had this this additional building all the time that actually is a reference block. Okay, reference block from another file. If we take a look at the file, so here it is, we can just manipulate it. I mean, we can insert a new window. Okay, we can change the hatch pattern of this object. Let's sign here, for example, a solid hatch pattern. Okay, and when we're ready, we need just to save this, go back to the main model, and just from the block manager, tell this block to update. Okay, just close this, and we see how it has updated with new information. Okay, and also this model looks accordingly. I mean, with the hatch patterns assigned, and also with the 2D representation of the visual objects inside this model. It is important that when you insert this block, you choose the embed and link option, by the way, okay, in order that all the objects show in a proper way. So I guess I've shown you pretty much what I wanted. Just one last thing, you know that from the VisualARQ website, you can download the program. You have here some material to learn VisualARQ. There is one tutorial to step-by-step learn how to generate this project. Okay, and there are some examples also for VisualARQ Grasshopper styles and for VisualARQ Grasshopper components. So feel free to go through this learning material and send me an email for any question, any suggestion, or anything you want to share with us. Okay.
Thank you, Francesc. Great, that was wonderful. I assigned you some questions, and so you can read them as well while I ask them to you. First, it's important to know this. Michele asked, is it possible to use a VisualARQ without Grasshopper?
It is possible, but if you want to use these styles driven by Grasshopper, then it's not. I mean, you need to have Grasshopper installed to take advantage of these objects. Okay, and actually in VisualARQ templates, I mean, when we run, for example, a new file and choose a VisualARQ template, they already come with a set of objects, especially for furniture and element, that all of them are driven by Grasshopper. So if you don't have Grasshopper, you won't be able to use them at all. Okay.
Okay, so
my recommendation is, even though you don't know Grasshopper, it's important to have it installed. And actually, Rhino 6 will have Grasshopper installed by default. So right. I recommend it to have it installed.
This is great news. And following up, is it possible to create a VisualARQ new object and use it as a sort of cluster inside the definition of Grasshopper? And what it means is a sort of new VisualARQ object in Grasshopper.
Mm-hmm. Yes, it is. Actually, all the objects that we insert here can be referenced in Grasshopper. Okay, so basically here, I can now reference this furniture object. Okay, I mean, actually, I won't reference this object, but the style. Okay, so reference is furniture style. So set one furniture style and select the sofa. And now I can, I don't know, I can create a definition that, well, uses this style. Okay, so I could create a new object that, I mean, uses this style for the, I don't know, maybe just I have a point. Okay, and I want to create, I don't know, a new element. Okay, and in the option I have furniture option, sorry, element option, and now I reference this style here. Oops. Let me see what's wrong. Okay, I know, because this is a furniture. Yeah, sorry for that. So I need to use the definition. I need the furniture options instead. So this this object can be referenced to be included in one bigger definition. Okay, and then save it in one new style. Basically, the important thing is that at the end, all these parameters end up in one geometry component. Okay, and remember that this component is created from a Grasshopper definition. Okay, so at the end, the important thing is that this component finishes in one geometry param. Okay, in order that VisualARQ recognizes this object as a new component when creating a new style. All right. I mean, we can have we can have, taking this one step further, we can have a definition that, for example, places two of these objects in this on this line. Okay, so we take this position as the position of these sofas. So let's say, okay, so rather than sofas, we can have, I don't know, maybe another style, for example, chairs. Okay, so we would have an array of chairs or array of seats or any other option, and we could save this as a definition that it's a row of chairs, for example. Okay. Does it answer your question, Michele?
Looks like it. He said, thank you. I think, okay. Yeah, that's perfect. And is there a possibility to get schedule totals?
Schedule?
Totals?
What? Totals?
Yes.
Do you mean
I think
this kind of, no, sorry.
Yes,
this kind of job?
Yeah, I think so.
Yeah, since this is a polysurface, okay, when you create a new style, I mean, this is well, it's considered a closed surface. I mean, maybe you should, well, in this case, a surface. So when you create a new table styles, okay, you make sure, let's call this totals, for example. You need to make sure that select surface or polysurface, okay? And finally, here add all the parameters you want, like name or, I mean, remember that custom parameters can only be added afterwards. So here you can add new property fields, and I don't know, maybe we should create first a custom parameter, for example. Yeah, again, we can create the material, isn't it? I mean, the material is already here, so this is something that we can assign to that object. So we say this material is, I don't know, plastic. Okay. Now we can go back to the styles, and for these torus we add a new field. Well, actually we use this field for the material. Okay. And here we need to define the type is a open poly surface or surface, and the parameter would be material one. And now we can insert a table for torus and select this object, and this will show. I mean, we need to specify a name, of course. This we can call this T1, and just update this table to update it with information of this object. So any kind of geometry can be listed in VisualARQ tables.
And so also, I think Roy meant if it's possible to get the sum of area, for example.
Mm-hmm. Yes. Yeah, of course. Okay. If we go back to the other model, I think in this model there were already some spaces. Let's take a look at them, with this command. Okay, we just have two spaces. Okay, it's fine. So if we run the table command, there was already one table style for quantifying spaces. So just need to select them, and finally insert here the table with the name, the perimeter, the area, and of course any other value that you want to add. Okay, just need to go back to the table styles and select here the spaces, and doing right click you can add a new property field for quantifying, I don't know, whatever, like the volume. Okay. And here it is.
Cool.
What more questions, please?
Okay, yes. Is it possible to design walls from profile?
No, that's not, unfortunately. But remember that there is the option to create walls from solids. Okay, so let me show that back from this document. If we just draw, I don't know, a profile that goes, I don't know, I'm just doing whatever thing, okay? And we extrude this. Remember that you can, well, we make sure this is cap, because we need that this is a closed poly surface. So there is the option to convert this object into a VisualARQ wall, but we need to define a path curve. Okay, the path curve will be needed by doors and windows to identify where is the path of the wall. And now remember that from here you have this option from solid. Just by selecting a closed poly surface or solid, and finally select the curve for each path, we can convert this into a wall and then insert doors or windows in it. Okay.
Cool.
I mean, yeah, we need that the window is placed on the path of the wall, okay, in order that identifies its location and performs the opening on it.
Cool. And is it possible to create new material and also new definition documentations for walls?
What do you mean?
Exactly. That's one of the questions.
In terms of texture, you can assign textures to visual objects.
Maybe that's what she means.
I mean, you can select any style and say, okay, I want this to get one specific material, okay? Or if you're using V-Ray or Flamingo, you can just, well, here it shows a like other option, and then it browses the list of materials that you have available in this model. So was that the question? I mean, regarding the
I think so, but we'll wait for confirmation. In the meantime, can I ask you if it's possible to see the projection of the edges above the plan section, for example, beam or countertop?
The projection of what again?
The projection of the edges above the plan section.
For this model, for example, or?
No, I think in general. Yes, no, for this model.
Yeah, I mean, yeah, we need to take into account where is the cut plane positioned. Okay, so we need to change this cut plane in order that it cuts through the wall, maybe. Yep. 0.5. Okay. Now it cuts through the opening. And you wanted to see the edges of the projection.
Yes.
We can assign here some hatch pattern. Okay. And the edges are basically, yeah, the projection of this object. I mean, if this question goes for a particular kind of geometry, I would need to see this geometry. If I mean, if the projection is like what the user expects to be. Okay.
Okay.
So, yeah, more questions?
It says that it cannot see projection of the whole of the window.
All right. Well, in this case, I'd rather ask that person to send me the example by mail.
Okay.
So I can take a look to see what's happening.
Yes. So great. And the email is fsalla, right, at asuni.com. Okay. And I have one more question. What is the section attributes hierarchy? What overrides what?
Yeah, that's a good question.
Yeah.
When by default, all the objects, for example, a box, has the section attributes set by parent, okay, or by layer in this case. So that means that, yeah, any change that you don't hear will affect that object. But in case of visual objects, for example, a wall, we set, for example, a generic 200 wall, which already has some hatch patterns. If we see that from the top viewport, we see that. If we change the hatch pattern of this wall, it won't change anything, okay? Because the wall has already some hatch pattern, in this case, the style. So we should go, in this case, to the style dialog for this wall, if we want that this takes the hatch pattern directly of the object, and say, okay, this structure that now takes this single hatch pattern, just takes it by parent, okay? And now it looks at the attributes of the, of the higher category, which is the styles name, and says that this is by parent. And in this case, it would take the attributes of the object, okay? We set by object. So basically, what it's defining in the styles is the more important. But as long as they have all these attributes by parent or by layer, they will get these attributes by layering. Actually, in this case, the material or the material of this glass component of that window, if we take a look at its styles property, you see that it's this component goes to the layer glass, and the material is set by layer. So no matter that this leaf has the attributes by parent, because the important thing is what the final object or final component has. Okay, that's why we have now here a glass layer and takes one specific material, and for the reason we see that in transparent material.
Cool. Thanks, Francesc. And since you mentioned it before, you hinted at it, can you tell us a little bit about the integration with Rhino 6?
Well, this is a work in progress. So we are working on adapting VisualARQ to Rhino 6, and that's all I can say. So there is nothing public yet, unfortunately, to test out. But
we were hoping you would have some scoop, but okay, we'll have to just wait and see. Okay.
Yes.
Yeah.
Patience.
Otherwise, they'll have to kill you. Okay. So now
we're all looking forward to have VisualARQ ready for Rhino 6.
I know. So we've had, a couple of other questions, but they came, and I think you already answered them throughout the presentation. Mm-hmm. Anyway, I think I'm going to send you all the questions we've received with the email of the sender, so you can contact them and have a conversation with them.
Exactly.
And
we can see all these particular cases to find a solution or to see how it looked like.
And that's fantastic, and thank you for following up with them. That's great. That's priceless, if you ask me. And because we're out of time, I will have to take the screen back. And let me see if you can see my screen now. And I will have to start saying my goodbye. And thank you, Francesc, for this awesome presentation. We've waited a little bit, but we couldn't wait to see what VisualARQ 2 was all about. And thank you all for attending. And this is where you can find VisualARQ 2 on the Novedge website. We also have Rhino, so you can get it all done under one roof. And I want to remind you that we're on Facebook, Google+, Twitter. You can check it out and get all the news, promos, latest deals. We're always, you can find us online in many places. And next week, we'll have a webinar on Keyshot 7. And to watch today's webinar, check out our Novedge YouTube and Vimeo channels. Our webinar playlist has webinar for every software taste. Thanks again for joining us today, and have a wonderful rest of the day. Bye-bye, Francesc.
Bye-bye,
thank
Barbara.
You again. Bye-bye.
Thank you. Bye.